Hey everybody, it's Miss Berry. I'm just gonna make a quick little video here to finish up what we did not get to cover in class today. So I'm just gonna go ahead and flip the camera around and we are going to look at the Smartboard notes. All right, so we left off, we had just finished this problem here. We were add, subtract the following rational expression, simplify your answer, same directions for our next problem. So we have a much more complicated expression here. We have z plus 4 over z minus 1 minus z minus 3 over z plus 6 minus 2 over z squared plus 5z minus 6. I need to back up right here and make sure I have my pen clicked. Let's see, there it is. Now let's go back. My bad, sorry. Okay, so like I told you guys in class, the steps here to add or subtract these rational expressions is we have to get the LCD. Apparently it still doesn't want to write. There we go. Come on now. Okay, there we go. Let's try. Okay, LCD. So to get the LCD here, we need to factor this denominator first. This one looks pretty easy to factor. You can see it doesn't have a leading coefficient other than 1 in the front. So let's see if we can easily factor this one. We're looking for factors of -6 that would add to 5. So let me go down here to the corner. I can make the little table. Pairs of factors, sums of factors. So factors of -6, that would be like -1 and 6. You could flip it around and do -6 and 1, and then -2 and 3, or -3 and 2. All right, so adding these together, -1 plus 6, that would be +5. So there's our factors that we're going to use. Let's see if I can circle that a little better. Ugh, yeah, it just looks even worse. Let's do like this. Okay. All right, so we're going to use those factors. Remember, our variable goes first. So z goes first. Then we just put in our factors, so -1 and +6. Right, so now that is factored. All right, so constructing our LCD, let's look at our denominators. LCD again stands for least common denominator. We have a z minus 1, we got a z minus 1 over here, then we have a z plus 6, and then another z plus 6. So that's our LCD, z minus 1 and z plus 6. All right, so now we're going to go through and we're going to multiply each term on the top and bottom by whatever it's missing out of the LCD, or whatever's missing from the LCD. So in this first term, we're missing a z plus 6. So we're going to multiply the top and bottom by z plus 6. Z plus 6. This expression is missing the z minus 1. So go ahead and multiply top and bottom by z minus 1. And then this expression is not missing anything. It's got the entire LCD, so we don't have to do anything there. All right, so let's get to multiplying. We're going to have to FOIL this out on the top. Remember, we leave the bottom in its factored form and don't multiply it out. All right, so z plus 6 times z plus 4. So I'm going to FOIL this out. So z times z is z squared. Z times 4 is 4z. Plus 6 times z is 6z. 6 times 4 is 24. All that's over our LCD, z plus 6 times z minus 1. And notice how it doesn't matter what order it's in. You can do z minus 1 first. You can do the z plus 6 first. It does not matter. All right, and then minus. Going to FOIL this part out. That's a z minus 1 right there. Kind of looks like an n or 11, but that's a 1. So z times z is z squared. Z times -1 is minus 1z, or you could just put minus z. -3 times z is -3z. -3 times -1 is +3. That's all over our LCD. Z plus 6. Z, try that again. Z plus 6, z minus 1. And then the last one we didn't have to do anything to, so you're just going to bring that one on down. Z minus, or z plus 6, z minus 1. I'm just trying to write them all in the same order. Okay. Now I need to subtract these. I'm going to put a little parentheses around here, just so I make sure and remind, that just helps me to remember that I need to distribute the negative. The first fraction is going to stay the same. So that stays, and now this is going to become one big giant fraction. So let's write one big giant fraction. Put our LCD in the bottom. So we're just combining the top. The denominator stays the same. All right, so z squared plus 4z. Oops, I'm sorry. We had like terms there, didn't we? My bad. Let's go back and combine those like terms. Let me switch my pen color so we can combine those and not look too messy. So it's going to be a plus 10z. 4 plus 6 is 10. Negative 1 minus 3, that becomes negative 4z. Nothing to do over here. All right, so let's go back to black. All right, so again, the first expression, the first numerator stays the same. Z squared plus 10z plus 24. Now we got to distribute this negative. So distribute the negative to each term. Just drawing little arrows for each term that we need to distribute the negative to. So that becomes minus z squared minus a negative 4z. And then minus 3. And then very last one, we have a minus 2. Okay, so now let's do some work in the numerator, simplify this a little bit. This double negative is going to become a positive. All right. Now let's go ahead and combine like terms. Let's see. I think I'm going to have to insert a blank page right here. Let's do this. There we go. That's better. Okay. Okay, or not. There we go. All right, so z squared minus z squared. So those cancel. All right, so those just canceled out. All right, now do you see any other like terms? 10z plus 4z is 14z. 24 minus 3 minus 2. So 24 minus 3 would be 21. Minus 2 more would be 19. Over our common denominator, z plus 6 times z minus 1. Now your last step is to think, okay, is there anything in the top that I could factor? 14z minus 19. There's no common factors up there, so you are all done. So all they asked us to do was just to combine or add or subtract, and combine like terms and simplify completely. So we're done with this one. All right, let's look at a multiplication problem. So we did some subtracting. Adding is much easier. You don't have to worry about distributing the negative. But also with adding, you do have to also have a common denominator. So just don't forget that. So if you're adding two fractions, you have to have a common denominator. If you're subtracting two fractions, you have to have a common denominator. Now, if you are multiplying two fractions, you do not have to worry about a common denominator. So let's write a little note there. All right, so no common denominator required when multiplying or dividing fractions. And of course, I'm just using the word fractions here as like a shorthand version of saying rational expressions. Okay, so let's look at the directions here. It says multiply or divide the following rational expressions as indicated and simplify your answer. Okay, so we're just going to have to remember that our answer needs to be in simplest form. This problem is going to require us to do a little bit of extra side work, so I think I'm going to go ahead and insert a blank page just in case. And then we will, let's just go ahead and throw this over there on that blank page. Oops, I think I hit the wrong thing. Let's do this again. Sorry, guys. Insert a blank page. There we go. Okay. Now let's do this. All right. So it says multiply or divide and simplify your answer. Okay, so before we multiply or divide, you want to make sure that all of your numerators and all of your denominators are factored completely. All right, so definitely going to have to do some work here, and then definitely going to have to do some work here. These denominators cannot be factored, so you don't have to worry about those. All right, let's look at this numerator. So this is what I'm actually going to do first. I'm going to just write this polynomial down. We're going to factor it. And then once we have it factored, we'll go back to our actual multiplying the fraction part. So 3z squared minus 19z, the first time I wrote it, I forgot to put the z there, minus 40. And then once we've factored that, we will go over here and factor the second one. That looks much easier to factor. All right, so here we have 3z squared minus 19z minus 40. First thing you want to do is try to look and see, is there any common factors we could pull out here between 3, 19, and 40? There's no common factors. 19 is actually prime, so there's nothing that goes into 19 except 1 and 19. So there's nothing we can pull out, but that's okay. We're going to use the AC method to factor this. The AC method says that we should take A, which is our first term, multiply it times our last term. So we're going to go over here to the side and do that. So 3 times negative 40 is negative 120. Now we're going to try to think of factors. Ooh, let me try that again. Trying to write a straight line there. That's a little bit better. Now we're going to make our little table so we can think of factors of 120, negative 120. So first column is pairs of factors. Second column is sums of factors. 120 is a pretty big number. So there are tons of factors of 120. I wouldn't put a number this big on the test, just FYI. But the homework does use numbers this big. All right, so let's try to think of some factors of 120. You could do like 10 and 12. So you could do negative 10, positive 12. You could do negative 12 and positive 10. What else? Let's see. I'm gonna pull up my little document camera, and we will do some of this work on our calculator. Well, I'm gonna try to get to it. Here we go. Okay, focusing, there we go. All right, so factors of 120, let's try 4. 120 divided by 4 is 30. Okay, so let's go and add that. 30 and 4. So negative 30 and 4, negative 4 and 30. I picked 4 because I remembered seeing it right here. So let's try 8. So those are numbers that are in our problem. So let's try those. 120 divided by 8 is 15. All right, so 15 and 8. So negative 15 and 8. Negative 8 and 15. All right, let's add these up. See if we have we're looking for the coefficient on the middle term here, which is negative 19. I'll put this back on full screen. All right, so we're just adding these factors together. All right, so negative 10 plus 12, that gives you positive 2. So 12 minus 10 is 2. Negative 12 plus 10 is negative 2. So not even close to our middle term there. Negative 30 and 4. Let's see, negative 30 minus 4, that would be negative 26. So we're getting closer. That would be positive 26, 30 minus 4. Negative 15 and 8, that would be negative 7. So definitely not close to negative 19. This would be positive 7. Okay, so we're still looking. Think of some more factors of 120. So you could do 40 and 3, right? Negative 40 and 3. Negative 3 and 40. Let's go ahead and add those together. All right, so negative 40 minus, or excuse me, negative 40 plus 3, that would be negative 37. So nope, that's not it. That would be positive 37. I'm going to go ahead and just continue my little table over here. Pairs of factors, sums of factors. You may already have it. You may already have found the factors. I genuinely do not know them yet. Let's see, we could do you do 20 and 6, negative 20 and 6, negative 6 and 20. Let's see. I'm just over here checking stuff in my calculator, just doing, looking for factors. I can pull up my camera so you can see what I'm doing. Let's see, I'm trying 120 divided by, does 15 go into it? Yeah, we did that one already, 15 and 8. Whoops, you can't see my calculator. Let's do 120 over 16. Nope, that one doesn't work. Has to be a whole number. 18. Nope. 20. Did we do that one already? I think we did. 60 and 2. That wouldn't work. We're trying to get to negative 17. Or negative 19, excuse me. All right, so let's go ahead and add these together. That would be negative 14. That would be positive 14. So we're not there yet. Let's see. This is what I sometimes do if I have really big factors. I'll just go to Google and type in factors of 120 in pairs. So there they are. Like I said, I wouldn't put a number this big on the test, so you wouldn't have to worry about that. Oh, there they are, 24 and 5. 24 and 5. All right, so let's get this back to full screen. Negative 24 and 5. So yeah, if all else fails, you can Google and look at the pairs of factors. So negative 24 and 5, negative 5 and 24. Let's see if you added these together, which one is going to be. Negative 25 plus, excuse me, negative 24 plus 5, that would be negative 19. That's the correct pair of factors right there. And here we're going to split up the middle term. When you do the AC method, which is what this is called, AC method. When you do the AC method, you can't jump straight to the answer. You have to use those factors to split up the middle term. That's going to become negative 24z plus 5z. Everything else just gets dropped down. So just drop this down, 3z squared, and then minus 40. All right, so now you have 4 terms, so you're going to factor by grouping. All right, so group the first 2, group the second 2. Now you're looking for common factors. All right, so what's common in the first 2? 3z. So if you factor that out, you're left with z minus 8. All All right, so you want to get another z minus 8 over here. So we could do that by factoring out a positive 5. That would leave us with a z minus 8. All right, so you know you're on the right track because you've got the same thing here and here. So the same thing inside the parentheses. Sorry, I keep having to go back and forth and doing this. All right, so now you're going to pull out the common factor, which is z minus 8. Then you have to write the leftover stuff in the second set of parentheses. So 3z plus 5. All right, so let's put that as our new simplified numerator. Z minus 8, 3z plus 5. Okay, now let's look at this little guy. We can probably factor this in our head. So you're looking for two numbers that multiply to give you 24 and add to give you negative 10. So that would be 6 and 4, right? But they both have to be negative because they got to add to negative 10. So that would be negative 6 and negative 4. So negative 6 times negative 4 is positive 24. Negative 6 plus negative 4 is negative 10. Now you could make a little table for that. If you couldn't do that in your head, that was totally fine. All right, so let's go to the next page and then we'll actually go ahead and multiply these. So let me write it down on my paper so I don't forget what our simplified numerator was. Okay. All right, so let's write this down in the simplified form. We have in the numerator over here, z minus 8, 3z plus 5 over z minus 4 times z minus 4 times z minus 6 over z minus 8. All right, so when you are multiplying two fractions, you can cancel either top to bottom or diagonally. So you look in this fraction, you say, okay, is there anything I could cancel up and down here? There's not, but I could cancel 7 minus 8 diagonally. And then I could also cancel z minus 4 diagonally. Z minus 4 is here, z minus 4 is here. And then I would just write my leftover stuff. So in the top over here, I have 3z plus 5 left over. And then times z minus 6. Nothing left in the denominator, and you're done. All right, so that's multiplying two rational expressions. Let's look at a division problem. Here's a division problem. Again, we have some numerators here that are going to need some work. Division is a little bit more complicated division is a little bit more work compared to multiplication, but it's not terribly difficult. All right, so I think we could factor these pretty easily. So let's see if we could factor these in our head. X squared minus 7x plus 10 over x plus 2 divided by x squared plus 3x minus 40 over x plus 2. All right, so here we have two polynomials in the numerator that have leading coefficients of 1, so they're going to be pretty easy to factor. Excuse me. In this first polynomial, you're looking for factors of 10, so things that would multiply to give you 10 and add to give you negative 7. So 5 times 2 would give you 10, or you could do negative 5 and negative 2, and those would add up to give you negative 7. Okay, so that's the factor numerator there. All right, and then here, factors of negative 40 that add to 3. Let's think factors of 40. Factors of 40 that add to 3. Thinking like, let's make a little table for that one. Pairs of factors, sums of factors. So factors of negative 40, 10, negative 10 and 4, negative 4 and 10. That's not going to work right because that gives you negative 6 and positive 6. All right, so let's think of some other ones. Factors of 40, 5 and 8. So you could do like negative 8 and positive 5, negative 5 and positive 8. All right, so negative 8 plus 5, that would be negative 3. So we're close. 8 minus 5 will give you positive 3. So there's our factors. So that's going to factor into x minus 5, x plus 8. Okay. I don't know why I was using z's over here. That was my bad. I guess because we were using z's on the last one. Let me fix that. I bet y'all were like, what in the world is she doing? All right, let's try this again. What do we say? It was z minus 5. No, I said z again. X minus 5, x minus 2. All right, so let's rewrite what our problem looks like just so it looks a little bit neater. Over x plus 2 divided by x minus 5 times x plus 8 over x plus 2. You don't have to put, I put parentheses around the denominator over here. You don't have to do that. Let me erase them. It's just so don't get confused. Okay. All right, so when you are dividing two fractions, you probably remember you have to do, you have to multiply by the reciprocal, also known as keep, change, flip. Again, the fancy word for this is multiply by the reciprocal. All right, so you keep the first fraction the same, you change this operation to multiplication, and then you flip the second fraction. All right, so let's do that. Keep the first one the same, x minus 5, x minus 2 over x plus 2. Change this operation to multiplication, flip the second fraction, so that becomes x plus 2 on the top, and then x minus 5 times x plus 8 in the bottom. Okay. So let's, now we can go ahead and cancel any common factors. The x minus 5 in the top over here cancels diagonally over there with that x minus 5. And then additionally, we could cancel this x plus 2 and this x plus 2. Okay. And then nothing else cancels, so you just write the leftover stuff. So that's x minus 2 in the top, and then x plus 8 in the bottom. And again, nothing here is going to cancel. They have to be exactly the same to cancel anything. So we can't, we can't just go in here and cancel those x's. It doesn't work like that. They have to be exactly the same expression to cancel. All right, so that's everything from operations with rational expressions. The last topic I need to cover is called simplifying complex rational expressions. And I'll just highlight here what the definition of a complex fraction or a complex rational expression is. It's just a fraction where the numerator or the denominator or both contains a fraction. Okay, so sometimes you might have like a fraction over a fraction. Sometimes just the denominator has a fraction or just the numerator has a fraction. So it says one way to simplify complex fractions is just to simplify the numerator and denominator separately, and then keep, change, flip, just like we did in the last example. Another way, which is faster, and this is what I'm going to show you, is to multiply the numerator and denominator by the LCD, the least common denominator, of all of the fractions that make up the expression. So let's do an example of this. So again, what we're going to do here is we're going to multiply the top and the bottom by the least common denominator, the LCD, of all of the fractions that are in the complex rational expression. So let's look at an example. We're going to start off with an easy example, then we'll do this one, which is harder. All right, so let's look at the first one. Here we just have a fraction in the bottom. You have 12x plus 48 divided by 3 minus 48 over x squared. Okay. So you only have one little fraction to worry about here. You may need to pause the video to go ahead and write the question down, but I'm going to go ahead and get started. We only have one fraction to worry about, so the LCD has to be the denominator of that little fraction. Right, so the LCD is going to be x squared. Right, so the way that we can easily simplify this is you multiply the top by x squared, multiply the bottom by x squared, and then that's going to get rid of all of your fractions after this step. All right, so we're going to distribute this to each term. All right, so 12x times x squared, that would be 12x to the third plus 48x squared over. Now we're distributing this on the bottom. 3 times x squared would be 3x squared. And then here the x squared and the x squared cancel out, so you just have minus 48. Now all of our fractions are gone, and you can simplify from here. I guess really we could have just not multiplied that on the top, because now we have to pull it back out. That was my bad. I wasn't thinking. So on the top, you don't have to multiply that out. Just leave it as it was. You can see I just put it back into its factored form. Now let's see. 3x squared minus 48. Are there any common factors there? Let's see. 48 goes into 3. It does. So you could pull out a 3 here. That would leave you with x squared minus 16. Looks like there's some more common factors up here that we could pull out, right? So 4 goes into both of those. So you could pull out a 4 on the top. That would leave you with 3x plus, what would that be, 12? And there's more common factors. Goodness gracious, let me erase that. Trying to do this all in one step. Yeah, that was my bad. Sorry, guys. All right, so what's the common factor up top? It's actually 12, right? So pull out a 12. You're left with x plus 4. All right, and then down here in the bottom, that 3 is just going to stick around. You just drop it on down. But this is a difference of squares. So x squared minus 16 can be factored into x minus 4 times x plus 4. So let's write that down. So x squared minus 16 factors into x minus 4 times x plus 4. Now go ahead and cancel any common factors. The x plus 4 cancels with the x plus 4. This is going to reduce, right? 3 goes into 12 4 times. All right, and then we are left in the top with 4x squared. And in the bottom, we're just left with this x minus 4. And you're done. Again, these 4's don't cancel. Remember, the expressions need to be exactly the same in order to cancel them. This 4 is being subtracted from x. This 4 is not being subtracted from x. So they do not cancel. All right, you guys, let's look at one more. You can see this one is obviously much more complicated because it has more fractions. All right, so that was the first method, is to find the LCD of each little fraction and then multiply every term by the LCD. I'll show you the alternative way you can do it on this example. So the alternative is just that you look at the numerator first, simplify that, make it into one fraction, then look at the bottom, simplify that into one fraction, and then keep, change, flip. So let's try that one, and then you can choose which method that you want to do. All right, so we're going to look at, the numerator first. Okay. So 1 over 5y plus 1 over z minus 6. All right, so the LCD here would just be 5y times z minus 6. All right, so you're just going to multiply by the missing piece. Here, in the first fraction, the missing piece would be z minus 6. Here, again, multiplying top and bottom by z minus 6. Here, the missing piece would be 5y. Okay. So let's see what we're left with. In the numerator over here, we have z minus 6. Again, I'm leaving the denominator the same, I'm not multiplying it out, plus 5y over, same thing, 5y times z minus 6. All right, now go ahead and combine the top. Denominator stays the same. Z minus 6 plus 5y over the common denominator. Okay, so that's our simplified numerator. Z minus 6 plus 5y over 5y times z minus 6. Now we're going to go over here and work on the denominator. Let me draw a little line here. So we're just going to say this is all of our scratch work down here. Now let's do the denominator. All right, so we have 1 over 3z plus 5y over 3z squared minus 18z. All right, so we're going to combine these, but to do that, again, we need an LCD. We need a least common denominator. In order to find the least common denominator, both of the little denominators here need to be factored. So go ahead and factor this one. You could pull out a 3z. You'd be left with z minus 6. All right, so now we can easily see, okay, both of them have a 3z, so that's part of the LCD. And then this one has a z minus 6, so we got to put that in there too. Let me see if I can write that all in one line. I have to move that over a little bit. Okay. So the LCD equals 3z times z minus 6. Okay. Now we're going to, just like we did over here, we're going to multiply by what's missing. So this one's missing the z minus 6 from the denominator. And this term isn't missing anything. It's got both terms from the LCD. So that one doesn't need to be multiplied by anything. So here, 1 times z minus 6 is just z minus 6. Denominator is 3z times z minus 6. Sorry, my handwriting's so sloppy. Plus 5y over the common denominator, 3z times z plus 6, z minus 6. All right, then just combine the top, denominator stays the same. Z minus 6 plus 5y over common denominator, 3z times z minus 6. All right, so z minus 6 plus 5y over 3z times z minus 6. All right, so now we have a fraction over a fraction. Now we can keep, change, flip. So let me see if I can, I'll just insert a blank page here and then we will copy that over. I'm going to write it down on my paper so I don't mess it up. Thank you for being patient with me, you guys. I'm recording this on Teams, so I have to do it in one take. I don't have any way to pause it and fix any mistakes and then come back and correct it. So I have to do it all in one take. So I appreciate you being patient with me. All right, so here's what we have going on. We have z minus 6 plus 5y over 5y times z minus 6, all divided by z minus 6 plus 5y over 3z times z minus 6. All right, so we're now going to keep, change, flip, or multiply by the reciprocal. Keep, change, flip. So keep the first fraction the same. change the operation to multiplication, and then flip the second fraction. All right, so z minus 6 plus 5y over 5y times z minus 6 times, so change the operation to multiplication, then flip this one. So that's 3z times z minus 6 over z minus 6 plus 5y. All right, so let's cancel any common factors. The z minus 6's cancel. And then, super great for us, this z minus 6 plus 5y, that whole thing cancels. So you're just left with, in the numerator, 3z. In the denominator, 5y. And no common factors here, nothing reduces, so you are all done. All right, you guys, that's everything for section 1.4, which was about rational expressions. If you have any questions, you can let me know. Otherwise, I will see you guys soon.